Hey geometry geniuses, wanted to talk to you today about reflections. In 9.2, this is after learning about translations, just where we were just moving shapes along. The objective of this section, believe it or not, is to find reflection images of figures. With the example seen here, this is a little tricky because you might think reflection like I'm looking into a mirror, and in a way you are, and in a way that's totally what's going on here. But now that we work with shapes that are reflecting over some line, it's as if we have to rotate everything that's going on with the shape to make it appear as if it's a reflection over a line of reflection. So this breaks it down a little bit further. So our reflection across some line, whatever line it may be, in this case line M, is called the line of reflection. It's a transformation with the following properties where a point A is on line M, then that happens to just stay where it is and just gets rewritten as A prime. So notice how A is on this line here, and A prime just is the same exact point. But notice that B and C move over to the other side because they're moving over this line M, creating B prime and C prime. The notation that will come up here looks like this. There we go. Now that that's out of the way. The notation will say something to the effect of a capital R going over some line and then the shape that you're being asked to reflect. So notice down here, the reflection across line M that takes P to P prime is written like this. So that may come up. For this, we'll go back and hang out with Lisa. So this is a reflection. Let's make this one a bit easier. So let's say that we are going to be reflecting our pre-image, the bottom one here, to the image up here. And this is over the line y equals 1. So let's notice some features here. That the bottom left point was yes, it's 5 units away from this line here. So when we flip that over and reflect it, we want it to also be 5 units away from the line here. We do the same thing with this point down here. This 5, -4 was 5 units away. So we make this 5 units away from the yellow line, y equals 1. So it makes sense that the x-coordinate's retained, at least with this example, but notice that there's no real coordination or pattern with the y-coordinates. Those change up for sure. And you just kind of have to think it out strategically, thinking, all right, this is 5 units away? I need 5 units away up here. And you do this for all the shapes, which is a little tricky. And you can also see it with the top left, top right. These are 1 unit away from the line of reflection, so it makes sense that they would be 1 unit away above the line of reflection. The line of reflection will sometimes change and look like this, depending on what the problem's asking you. Sometimes you'll have to accommodate that. But for the most part, these are going to be horizontal lines or vertical lines that you have to reflect over. So that makes it a bit easier to work with. So for this example here, this line of reflection is where x equals 5. If we look at some of these points, the way left was 2 units away. Sorry, how many? Yeah, 2 units away. So the bottom left is 2 units away. So it makes sense that this is 2 units to the right of the line of reflection in this case. Same with this point here, 1 unit away. So make it 1 unit away here. Notice how these pictures are looking in different directions, similar to a reflection. They look similar, but they're kind of facing in different directions. So important thing here is to count how many units away each point is from the line of reflection and then map that over. The goal is that you want your shape to look as if it's reflecting into a mirror. Hope that helps. If you have any questions, please bring them to class. Thanks for watching.